We have done some good cleanup by removing some columns we don't need. Now we need to mold the data into data we can use for training. This involves reviewing the data values within the rows and making a decision about whether to keep the row, ensuring that the data types of the columns are what we need, and, if required, creating new columns based on existing data. Let's recall that our solution statement said we are trying to find flights that arrive 15 or more minutes late. That is, those flights in which arrive delay 15 is set to 1. Since arrive delay 15 is the result for which we are predicting, we cannot process any rows for which the value is not 0 for false or 1 for true. Unfortunately, if the column does not have a value, the CSV import process will set the value in the column to NA. To make matters worse, the DOT export process will sometimes set columns to an empty string when it does not have a value. So we need to drop all rows for which arrival delay 15 is set to NA or an empty string. We should also do the same filtering for departure delay 15 since we might want to use that field in our prediction. We can easily filter the rows for NA or empty values in either column. Notice that this code stores the filtered rows in a new data frame named onTimeData. I like to create new data frames when I reach major checkpoints like starting to drop rows. This lets me easily go back to the before state. Now that we've filtered the data, let's compare the number of rows in the new and old data frames. The difference in the number of rows show that there were some rows that we needed to drop. Another basic way to mold data is to change columns into a more useful data type. Let's use the Environment tab in RStudio to look at data types of some fields. We see some fields, like distance, that should be numeric or strings. This can make this field less useful because algorithms may not see this as a continuous set of numbers, but rather as a discrete set of strings. So let's change the format from string to numeric. Changing the format of a column and all the data for the rows in that column is hard in some languages, but simple in R. We just type in the simple command. And we change all the rows in the column in one line. We can also convert other strings to integers. Now let's take a look at the arrival and departure delay 15 fields. Sometimes algorithms perform better when you change columns into factors. Factors are like enumerated types in other languages. Changing the column to a factor allows the algorithm to use counts of the number of times the column was a certain discrete value, like the number of times the value was 1 versus the number of times the value was 0. Let's also change some other columns to factors. Notice that for each factor column, the number of distinct values is listed. Also notice that this number of distinct values is relatively low for the 20,000 plus rows. If this number of values was not low, then the field probably should not have been changed to a factor. We can easily change the data type back by using R's asNumeric and asString functions. Now reviewing the data, it looks like we have it in a form we can use. However, before we can use this data to train a prediction, we need to ensure the distribution of the data will allow us to train a prediction. This is driven by data rule number 3. Accurately predicting rare events is difficult. The basic issue with a rare event is they're rare. So the probability of you having one in your data is low, and the probability of accurately training the algorithm to recognize this event is also low. We only need a few percentage of the event to be able to train, but more is better. To ensure we have a reasonable chance of correctly predicting if the flight will be delayed, let's check our newly cleaned data. Remember, we're using arrival delay 15 equals 1 as true, and arrival delay 15 equals 0 as false. Let's see how many delayed versus non-delayed arrivals occur in the data. We use the tapply function to see how many times arrival delay 15 is true and how many times it is false. We definitely have a number of delays, so that is good. Let's compute the prevalence of delayed flights in the data. We have about 20% delayed flights, which means we can reasonably train our prediction model using the data we have. So congratulations, we have our training data. But does anyone remember how we got here? This brings up data rule number 4, track how you manipulate data. A lot of the manipulation of data you do in machine learning is trial and error. When you manipulate data, it's easy to change the meaning of data. This can be done intentionally, but also is done unintentionally. By keeping track of the manipulations of data, you can always reproduce your data at any step and see where you went wrong. With R and RStudio, the easiest way to keep track is to create an R script file. You can copy commands from the command line to the R script file and then save them to disk. Like all coding, you should ensure that you have some sort of source control to track changes and allow you to restore things that you might have accidentally deleted or altered. Let's summarize how we prepared our data. We first discussed the various data sources and went to the DOT site to select the data we are using. Once we had the data selected, we downloaded it as a zip file that contained a CSV file. Using R, we loaded the contents of the CSV file into a data frame. From there, we cleaned the data by removing extraneous fields. Then we molded the data by removing rows we could not use and changing the data types in columns to what we needed. We also verified that we could use the data for prediction. And along the way, we discussed data rules that guided our work. In the next module, we'll select the algorithm that will be trained by our data to produce our prediction model.